Hey everybody, it's Mr. N here again, and per your request, I'm doing a second review on sketching derivatives. Okay, so over here we have f of x in red, and we need to sketch the derivative f prime of x. So let's go ahead and do these. These graphs, by the way, most of these were made on Desmos, so let's see how they work out. This first one, I do want to clarify and point something out. This is right here a point. It does come to a point. So if you can't tell really well, I'm telling you, it does come to a point, and that was the intent of it. Okay, so what we want to do is we want to find our horizontal tangents first. Just like in the other videos, we said always look for the horizontal tangents, and those are where the slopes are going to be 0. Now we look over here, and we see that these, on this end, are positive slopes. They go positive, positive, all the way up to this point, where it flattens out to 0. So that means I'm going to be above the axis. These seem like they're really steep, so over here, this slope will be up here really steep. As the slope gets closer to this horizontal one, notice how it decreases as a positive slope in value, so it's going to come down. Now this has some sort of curvature, some exponential curvature. If you assumed that this was parabolic in nature, then you would get something linear. But this does have some sort of curvature to it that is more than just a quadratic. And again, you can't really tell that from this, so we're just going to assume that. If you did do it as linear, that's fine. You could do it as linear, but remember, these slopes decrease, but then you get to this part where there's 0 right here. So I do have a horizontal tangent right at this blue spot right here, and then it's going to continue somehow down, but notice the curvature, and it comes to this point, so it's going to increase in negativity to that point where it's a discontinuity. So I'm going to go ahead though and sketch this so that it looks something like this. It's going to be parabolic, and not parabolic, but some sort of polynomial of a higher degree. So I'm going to bring it down like that, and then over here it's going to continue on. Now I don't know if it stops at this value or it continues on infinitely. I can't tell by that graph. It could just be a discontinuity that stops right there based on the slope, or it could continue down. I can't zoom in quite well enough to tell. Okay, for the next one, so I'm just going to go ahead, and on this one I will just leave it as an arrowhead. You could have closed it out right at the axis. That would have been okay as well. I'm just giving you an idea of what it could possibly look like. Again, zooming in or knowing what the exact function is, and I don't remember what the exact function is. I just know the intent was to get something with a point there. Okay, on the other side, the same type of thing is happening. Over here, though, I am going to reach, notice these are all negative slopes along this end. These are all negative slopes to 0, so I'm going to be below the axis. Over here, these are negative slopes and then positive slopes. So I'm going to come up here from a positive slope. Again, I can have it as a discontinuity and then come down, or I can put an arrowhead because I'm not quite sure what's happening right there. I'm not zooming in well enough to be able to determine that. So I will just go ahead and put it as an arrowhead, and this is going to come down through this 0 again, and it'll probably reach its most steepest value right there. It'll peak out somewhere right there, and then it'll come back up and through. So that is what the derivative of that looks like. Now moving on to number 2. For number 2, if we take a look at this, I can, let's do a different color here. So if we take a look at this, I can assume in this one that this, and I know it, is a point. There is a discontinuity right there. So over here, this is a horizontal slope for this part of it. So that's going to be at 0 going in this direction. There's my discontinuity. Over here, I could try to estimate what the slope is. I'm going to go up 2 over 1, negative 2. So let's see, up 2 over 1. So it is negative 2. So my second graph will be down at negative 2, and it'll be from negative infinity all the way open at 0 because there is a discontinuity there. Alright, let's move on and see what we could do with the rest of these. Okay, so for number 3, this looks like a sinusoidal wave. of some sort, some trigonometric function. So, because it looks like it continues on even though the graph is cut off there. So let's work with it being that. But again, we want to look for the horizontal tangents. Horizontal tangent, horizontal tangent, horizontal tangent. So there's a 0 right there. There's a 0 right there. Here's another one. There's another one. So let's look at the slopes. Over here, these are positive slopes. Above the axis, flattens out, negative slope, reaches a peak right about right there as far as minimum value, I should say, then comes back and goes the other way. So tracing all of this together, we end up with, we start as a positive slope. Over here, let's just say, let's just say that that's about -2, roughly. I'm just giving that a good guesstimate right there. And we'll say that right here is also about this will be, sorry, +2. So we'll just put it right here. Over here, again, about a -2 value. So we're just going to fall. And I'm just estimating what these slopes are. I'm just kind of taking my pencil and saying, okay, and I draw a line right there, draw a tangent, and kind of count it out. Draw a tangent, count it out. Draw a tangent, count it out. So if I extend the tangent out, I can determine what that slope would be, and I'm guesstimating it to be a -2 or +2. So this will come up through here, down here, reach that. Come up, reach that. Oops. Let's try to smoothen that out a little bit. Come through like this, come through like that. So that's what that will look like, a little bit smoother. You could probably do it better than I can. So that's what this would look like. Okay, moving on to the next one, we've got number 4 here. And taking a look at this, we see that these slopes are positive, but they increase in positive value to maybe right about right there. Don't worry about these values right here, because I just took this image from somewhere. So they increase in about maximum positive right there, and then they begin to flatten out again. And then over here, this is 0. They come down, and they probably reach about a negative, the steepness of them right there, and then they flatten out again. So let's see if we can create this derivative for it. Again, let's start with our horizontal tangents. It's going to go through 0 right there, and it looks like right there. So this is at 2, -2. So it'll go through 0 right there. And again, I said these positives are not so steep, but then increase, and right here is about the maximum steepness they will get before they go back to 0. So we're going to be above the axis somewhere. It's going to be maximum steepness, then come back down. So I'm just guesstimating what this looks like. These increase in slope value till it hits that peak, then comes back down. They decrease in slope value until they hit about right. We'll just kind of guesstimate right here, right around here. This is the maximum negative slope, or minimum, I should say, in this case. So we'll just put that point right there. So it'll come down through here and then come back up. Again, where did I put this point? I just took a guesstimate. You can try to calculate if you had a nice grid here and draw a tangent line and see what that slope would be and get a better estimate. But I just kind of quickly, I'm just drawing a sketch here. So this could have been lower, could have been higher up. This point could have been up here, could have been down here, just depending on what this slope value is. So something like possibly like that. Okay, moving on to the next one. Let's take a look at what we got. So for number 5, let's go ahead and take a look at this more in depth. Again, on this one, we've got a horizontal tangent right there. We've got a horizontal tangent right there. Those are our zeros. Now let's see. This slope right here appears to be where it's going to peak in positive value, and it appears to be pretty steep. Now I could again draw a imaginary tangent line along here, and for example, I could just draw this imaginary tangent line and try to calculate what that slope would be, but I'm just going to, for time reasons, just guesstimate and say, okay, it's about up here. And so that means this slope increases in value till it hits this peak and then starts going back down to 0. And what happens on the other sides? Well, it hits 0 and then the slopes go negative. They increase in negative maybe to about right there. So that's the peak. And then they go back to 0 as well. So maybe like this. And on this side, same thing. They increase in negative I should say decrease, but the maximum negative would be right there. So it's going to come through, and on this side do about the same thing. I'll just put that point right here, and we'll say it goes like this and then comes back up. Again, where to put this point right here, it's all based on what the slope is. Alright, so that's just a quick rough sketch of it. Again, this kind of smoothens out like this, just like it did on the other side. I didn't draw it so good. Alright, number 6 is kind of a mess. If we're trying to find the derivative of this, well, right here, obviously we've got a discontinuity. We can't do that. Notice how these slopes, discontinuity, I can't take a derivative there. And then the slopes continue. So I have this spot here where I can't do anything. And these slopes continue, and then they flatten out right here. So this is my horizontal tangent. That's where it is. So let's do segments at a time, and I'm going to do this first segment right here, and I'm going to talk about a few things that happen right there. So typically, whenever we say theorems, we're going to say it's continuous on a closed interval but differentiable at the open interval, because we don't want to take those ends into account so much. So right here is what we're going to look at, and let's see. For this one, the slopes are positive, they increase in positive value. They're actually decreasing in positive value, up to right there where they get to be 0 with a discontinuity right there. I don't know what's happening right there. I cannot take the derivative right there. So let's just go ahead and sketch what something like this would look like and say here is our 0 horizontal tangent. We're going to come through like this, and I'm just keeping a discontinuity right here. Let's not put it exactly at that point, just for sake reasons. Let's put it, say, right there, and we'll say, okay, there's my discontinuity. It comes to 0, and then these slopes start to turn a little bit negative, and now I can take a derivative at that point, but like I mentioned, whenever we are dealing with those theorems, we say it's continuous on a closed interval but differentiable on an open interval. So we're going to keep that like that, because if I were to take the derivative at that point, it's too uncertain. So we're going to keep that like that for now, not to make things too complex for you. Over here we've got, let's do this next branch. We've got a horizontal tangent right there. We've got obviously a discontinuity right there, so we can't take a derivative there. So this horizontal tangent, let's line it up probably like right here. So that's my 0. These are all negatives. They decrease in negative value until they get to 0. So we're going to go like this. So we could have started right down here and gone like that. That's okay too, because I don't know what that slope is. So we're going to go like this. And then the slopes become positive with the greatest positive somewhere right here. We'll put it up here. And then they go back down to, there's the other horizontal tangent right there, 0. So they increase in positive value. So to try to kind of, I'm going to do something a little different. I'm going to move that point a little down more. Let's move this point down here, just so that I can smoothen this curve out a little bit better. And then we said that this is right there is where it reaches its peak. And then we said it comes right back down to 0. And then the slopes turn negative again. So it's going to come back down to 0, and the slopes turn negative. Okay, so let's address something real quick. Right here you see this discontinuity right there, because this is a hole. This is a jump discontinuity. So what I want to do in my graph is I want to make sure I address that. And we put a hole right there. Just like over here when we said this right here was a jump. This is a removable discontinuity. This was my jump discontinuity, so I kept it as an open circle. So same type of concepts apply for these discontinuities. Over here, this is just a point. I can't find, there's no tangent to it. So we're going to keep it just like that. Alright, moving on to the next and the final problem here. Let's see what we got. We've got this situation, and these should be not too bad for you. And let's take a look at this. Over here, I've got a horizontal tangent. Oops. So I'm not sure what exactly I did, But let's take a look at that. I've got a horizontal tangent right here of 0. So I'm going to keep that moving along like this with those discontinuities. Now over here again, I've got a horizontal tangent, so I'm going to keep that horizontal tangent just like this again. So I've got two horizontal tangents that have a slope of 0. Now let's address this one. It goes through this point, it goes through this point. This is a slope of 2 over 1. So we're going to put this up here at 2, open circle, and we're going to go in that direction. And we're going to assume that that is an arrowhead there, so I'll just throw an arrowhead on here. So that's what this looks like. So let me clarify again. You've got this open circle, because I drew a lot of red here. This open circle, and that. That's what this graph looks like in purple. All right, well, hopefully this has helped. Again, practice these. These get easier as you practice them, and good luck with sketching derivatives.